Okay, this is part 2 of the video from chapter 7.2. I left off by finishing example 6, so we'll start up with example 7, where you're putting together different expressions by adding and subtracting them. In the first case here, I've got the square root of y in both of these terms. On the left half, I've got 5 of them. On the right half, I've got another 6 of them. Put those 5 and 6 together, and I've got 11 of those things called the square root of y. B, I've got 2 of these things that match. They're called xy to the 1/3 power. I subtract off another 7, again, like I said, they match, of these things called xy to the 1/3 power. Well, 2 minus 7 is negative 5. In other words, I've got negative 5 of these things called xy to the 1/3 power. Example C. In this case, these don't match these terms. I'm taking the cube root on the left of 5x to the 5th, and on the right, the cube root of 40x squared. But wait, notice that on this left side, I have something, well, I do have one set of 3 that, in this case, I've got more than a set of 3 x's. I've got 5 of them. I can get 3 of those out. And on the right side, within 40, I have a perfect cube. 8 is a factor of 40. So notice what happens. On the left side, I've got, I wish they had written this out. X cubed times x squared. I factored out one of those x's. So instead of it being 3 times this stuff, it became 3x because x came out. And where I'd had 5, and I took one set of 3 out, I was left with 2. So I'm left inside this radical sign with 5x squared. But on the outside, I'd already had 3 on the outside, and I got x out. Over here on the right, 40 is 8 times 5. 8's a perfect cube. The cube root of 8 is 2. So where I'd had x on the right side before, now I've got 2x. Since 8 came out of this 40, I was left with 5x squared. But now notice these match. Both of these things inside the radical sign, they are cube roots of 5x squared. I have 3x of them on the left and 2x of them on the right. 3x minus 2x is x. And inside the radical sign, I've got the cube root of 5x squared. Last thing to show you is this word problem. Hit the pause button and read this paragraph to yourself. Okay, I'm going to assume that you did that. And notice this formula that you're working with here, s equals km to the 2/3 power. Well, this table here gives you the values of k for several different mammals. So for example, a large dog, the value of k for a large dog is 11.2. S, as you note now, is the surface area of a mammal, a particular mammal. So if you want the surface area of a cat whose mass is this, well, remember it's this constant k times the mass of that mammal to the 2/3 power. So plug all of that together. If the general formula is this, and you plug in the information for the cat, the 10 is its constant from here from the table. The 5 times 10 to the 2/3, times 10 to the 3rd, that's the mass of this particular cat. Well, I can separate the 5 and the 10 to the 2/3. 5 to the 2/3 and 10 cubed to the 2/3. Notice this 3 and the 3 in the denominator are going to cancel, and I'm going to end up with 10 squared on the right. 5 to the 2/3, the best I can do here with this is put that into a calculator. It'll tell me it's approximately 2.92. So I've got that constant I had before, 10 times 2.92 times 10 squared. Well, 10 squared is 100. So this is 1,000 between these sets of 10. 1,000 times 2.92 is 2,920. And the surface area, therefore, of that cat is 2,920. What were the units again? They were up here somewhere. Oh, square centimeters. And that's the answer. All right, that's it for this shortened second part of the video. Come into class with any questions you have. I'm happy to go over them, but I'm not going to assign any specific problems out of the book. Instead, we'll work on some problems from the book in class, and then we'll have another set of homework tomorrow.